Welcome to the Math Kangaroo webinar that is co-hosted by AOPS. My name is Dr. Sarah Sagi. I'm going to be presenting the webinar today. I am joined today by two other representatives from Math Kangaroo. They are Joanna Mathewson, who is the CEO of Math Kangaroo. Would you like to say hello, Joanna?
Hello, everyone. Welcome.
And I'm also joined by Lucia Liu, who is our Chief Marketing Officer and also takes on a lot of other roles. And if you were going to start a Math Kangaroo Center, she would be a wonderful person for you to get in contact. Lucia, would you say hello?
Thank you, Sarah. Hello, everyone. Welcome to Math Kangaroo World.
So the topic of today's webinar is to find the joy in math. And we think that our Math Kangaroo contest is a really good way to make Math Kangaroo fun for everybody. So I want to set up a couple of boundaries. The first is that Lucia and Joanna are going to be able to stay with us, and they will be answering questions from the adults in the group in our Q&A. So if you have questions about that, they will open it in a little while. I wanted to go through the introductory information first, and then if you still have questions, you can address them to Joanna and Lucia in Q&A. For our younger participants, our student participants, if you want to communicate with me about the problems that I will be presenting, the best way to do that is through the chat. And for some of the problems, we will have polls, and the students will be able to participate in the polls to use their answers that way. So I really encourage the students to do that. This is supposed to be a webinar, but I always have a more interactive style. So you'll notice if you send me little things in the chat, if you have a little question or you want to send me the answer, I might give you a thumbs up or a little smiley face. I like to let you know I'm here. Okay. So that's a little bit of the background. Remember, polls are completely anonymous and no one can see your chats other than myself. So don't worry about that either. Okay, so why should we have a math contest for such young children? Math Kangaroo starts, we publish it as first grade. Kindergartners are allowed to participate, but they will participate as if they were in first grade, and a lot of them find it somewhat difficult, but it is a possibility. So we start our Math Kangaroo contest in first grade, and we have contests that go all the way through 12th grade. It's one of the few opportunities that young elementary school students have to compete in an annual contest. Why should we let our young children participate in contests? First reason is because it really builds their problem solving and critical thinking skills. Math Kangaroo contests also work a lot on reading comprehension. And one of the reasons kindergartners struggle a little is because we do have a lot of words to understand in our problems. We're very specific, and our examples will help you understand what I mean. But solving these problems is going to help children increase their creativity. It's going to prevent boredom because these are challenging problems, things that they might never ever see in school. We hope that they build some enthusiasm for math study. They can say, these are really interesting. I liked doing this instead of doing the boring stuff over and over again. Having an annual contest allows you to track your growth year over year, and you can build a sense of achievement. So also, just keep in mind that testing is always going to be a part of academic life. So if we can get our students used to the idea that there's a test and you can get through it and you can do well and you can feel accomplished, that will help them. Like I said, I really want everyone to have fun. I want you to have fun in today's webinar, and I want you to have fun in general when you're doing math or doing things that are challenging. Don't think of them as overwhelming. Think of them as something that you can achieve and you can build on yourself. Why is Math Kangaroo such a good experience for young children? Well, the first thing is that a lot of our problems are illustrated, and they're illustrated in an age-appropriate way. And this is something that you're going to see through the sample problems. Today, I'm going to show you what some of those illustrations look like. A lot of our information is actually visual. We try to keep the subjects of our problems relevant to the students' grade levels. So we're very, very careful in writing our problems that we actually keep the topics, things that a young child can understand and that they have familiarity with. Our contests are progressive. There are 3, 4, and 5-point questions on each of our levels. So students will begin with problems that hopefully are really achievable for them, and then they'll get continued to be challenged as they go through the contest. Our contests are for 2 grade levels each. So there is a contest for level grades 1, 2. There's a contest for 3, 4, a contest for 5, 6, all the way up to 11, 12. We do go through high school. And you are ranked, if you're interested in how you rank nationwide, you are ranked in your grade. So even though a first grader is going to take the same contest as second graders, they're only ranked against first graders. So you will find that these problems are going to be challenging, especially as we get to 4 and 5-point challenges. And they're not going to be stuff that are typically seen in school, but they're going to seem almost like puzzles or games for some of the children that they can figure out and use their creativity to solve. And that's a really fun experience. A little bit just in general about Math Kangaroo. Some people have not heard of us. We began in the 1980s in Australia, thus the kangaroo name. Over 6 million students participated in Math Kangaroo this year. The United States had over 50,000 participants in 2025. The majority, 75% of those, are elementary school students because there are other options for older students, but we are one of the best options for young students. Our test is 1 time a year on Thursday in March. And just to give you an idea, our questions are selected from hundreds of questions. We have an international committee that meets every year to determine which questions will be on the contests and at which levels. So we're very, very conscientious to make sure that we're using the best questions we possibly can. And we get nominations, proposals for questions from all over the world every year. The topics that would be covered on Math Kangaroo contests for young students would include things like ordering. What steps do you do in what order? Patterns, visual reasoning, 3-dimensional visualization. So can you turn objects? What happens when you build things on top or behind? We do use algebraic thinking, especially as you get into the 5 and 6 levels. Logic, even with young children, we'll use process of elimination or other types of logic puzzles. Probability, geometry, basic shapes for young children, but getting into some ideas of perimeter, area, other basic geometry concepts in upper elementary. And also number theory, things like place value, factors, and primes. So hopefully that gives you a little idea about the background for our Math Kangaroo problems, how we select them, and what we cover. We have Math Kangaroo educational courses, and in those courses, we teach a 4-step problem-solving strategy. I believe these problem-solving strategies work for even non-math types of problems. So the first is to understand the problem and to determine what it is asking. Okay, so that comes to the reading comprehension. We'll see that in some of the problems. Once you understand what you need to discover, what you need to know, then you need a plan to solve the problem. How will you do it? Are there intermediate steps? We frequently have multi-step problems. Carry out your plan as carefully as possible so that you're not making errors and you're organized. I always encourage students to use their scratch paper. So if you're going to be solving problems with me, now would be a great time to find your scratch paper so that you can work with me. And then look back and check and see if your answer makes sense. All right. So at this time, we should have our Q&A open. So if you have questions for Lucia and Joanna, now's an excellent time for the adults to use those. And I'm going to actually start to get into some of the math problems that we have. So I have several different sections of problems. This section is to show you how we illustrate our Math Kangaroo problems. So I'll start with a level 1, 2, then I'll do a level 3, 4, and then a level 5, 6. Okay, so on Michael's toy shelf, there are no turtles, no rabbits, and no robots. Which of these shelves could be Michael's shelf? And if my students would like to chat with me and give me the answer, that would be fantastic. Yeah, thank you. I have a lot of answers coming from the students. I appreciate that. So this is a logic puzzle. So again, I'm showing illustrations, but I'm also showing examples of logic. So we're going to use the process of elimination. If we have no turtles, we can cross off any shelves that have turtles on them. If we have no rabbits, we can cross off the shelf that has a rabbit. And if we have no robots, we can cross off the shelf with robots. So in this case, the correct answer is B. Okay, now I know some of you are older and you might think that was pretty simple, but remember, if you're in first grade, just being able to read that problem and be able to see all those pictures is going to be a good experience for you. All right, for level 3-4. And on this problem, I do have a pole, so you'll get to see the first example of a pole problem. On a regular die, the total number of dots on two opposite faces is always 7. Which one of the dice shown below can be a regular die? So regular has 7 on opposite faces. Here's a little bit of our vocabulary, right? What does the opposite mean? And I will launch that poll, so you can put the answer A, B, C, D, or E into the poll. Just a few more seconds and I'll close the poll and I'll go through the answer. I'm seeing a lot of correct answers in the chat as well. Thank you. All right, here we go. I'm going to share those results. So now you can see as a group, 82% of you have thought that the answer is A. Let's take a look and see if that's correct. So what does it mean when it says opposite faces? Well, on cubes, opposite faces could mean the top and the bottom. It can also mean the left and the right. And it could mean the front and the back. What it does not mean is that another word which would be adjacent. Adjacent is going to mean touching. So if I have a cube where I have a sum of 7 on touching sides, then I won't have a sum of 7 on the opposite sides. So if I look at cube B, 5 plus 2 is 7. So this is not correct. If I look at cube C, I have 6 plus 1 is 7. So that is not correct. If I look at D, I have 4 plus 3. And at E, I have 5 plus 2. So the only cube where I would have opposite sides would be A. And you can test this. You can think about what would be opposite. I could have 6 on the back side. I could have a 2 on the bottom side. And on the left side that I can't see, I can have 3. So that cube will work. All right. And now for my level 5-6. You'll notice level 5-6, I don't have a pretty illustration on this one. I went from the colorful illustrations on level 1-2 to a more monochrome illustration on level 3-4. And on level 5-6, we don't need an illustration for this example. Felix never tells the truth on Tuesdays, Thursdays, and Saturdays. He always tells the truth on the other 4 days. One day, Mateo had the following conversation with Felix. Mateo asks, "What day is it today?" Felix answers, "Saturday." Mateo says, "What day will it be tomorrow?" Felix says, "Wednesday." On which day did this conversation take place? So I have a poll for this one as well. I can launch that for you to answer. And you'll notice the polls have the questions restated in them. So if it pops up on your screen, you can read it right in the poll as well. Remember, for the adults who have questions, if you could put those into the Q&A so that Lucia and Joanna can help you with those, I'm going to focus on the problems with the students for now. Okay. Anybody need 10 more seconds and I'll close the poll. Okay. And here are the results of this one. The majority of students, 73%, have believed that the correct day of the conversation is Thursday. Let's take a look. There are a few ways to think about this problem, and that's one of the things I really like about Math Kangaroo problems is when I work with students, I might have one student say, I did it this way. So what a student might say is, okay, if Felix says today is Saturday and tomorrow is Wednesday, Felix is a liar. Felix is not telling the truth because it can't be Saturday today and Wednesday tomorrow. So we know that therefore it must be Tuesday, it must be Thursday, or it must be Saturday. Another student might say, but wait a second, Felix can never honestly say today is Saturday because if it is Saturday, he would be lying and he wouldn't say that it is Saturday. So that's another way I can tell that Felix is lying today. Okay, so we know it's lying. If Felix, and we also know that it cannot be Saturday, because Felix can't honestly say today is Saturday. So we can cross Saturday off the list. Saturday is not one of our options. If Felix says, what day will it be tomorrow? And Felix says tomorrow will be Wednesday, we know he's lying. And if today is Tuesday, tomorrow is Wednesday. So we know it cannot be Tuesday. We know it can't be a truth day. So that would be a Monday or Wednesday or Friday. Those are truthful days. So today must be D, Thursday. And the majority of you who got that right in the poll, congratulations. Good work on this problem. Okay. Changing the topic just a little bit. This is, again, you're going to see how we progress by levels. So this is a level 1-2 problem that has to do with visual and spatial reasoning. And I will have other questions for level 3, 4, and 5, 6 that have to do with spatial and visual reasoning as well. The buttons on Carla's sweater all look like this. Which one of these buttons could be from her sweater? So this is the one that we know. This is the one they're giving us. And they're asking which of the other 5 could be on the same sweater if the buttons are the same. There is no poll, so you can put the answers right into the chat. So you might try to see what's the difference between these buttons. What's one way we can tell them apart one from another? And what happens to buttons on your sweater? They're not going to flip upside down, but they could kind of rotate a little bit and spin, right? Nice. I'm seeing some really good work from the students. Okay, so one of the ways to look at this is to look at a detail on the button. And I'm just going to pick my favorite part of the button. My favorite part of the button is the heart. So I will want to be able to see a heart. So the heart is to the left of the square of holes. So this is okay. The heart is sideways, so this is not okay. This is okay. This, if I put it to the right, it would be sideways, so this is not okay. Now this one in E, when I look at it, if I turn my head a little bit or turn my paper, remember you can always turn your contest papers. This one looks like it would be okay. So now let's see what else I can do. I have this, to me, this looks like an elbow macaroni shape. I don't know what it looks like to you, but to me, that looks like elbow macaroni. If I look at A, the little circle and that elbow have been reversed, so that is not okay. If I look at C, that elbow is facing away from the holes in the button, so it is not okay. So the correct answer for this one, by looking at the different components on the button, is E. And a lot of students have that correct. So it is pretty tricky. There were some very subtle minor differences, so you can see how this could be a difficult problem for a first or second grader. Here we get a little more progressive. This is asking a little bit more of a challenge for third and fourth graders. Which pinwheel can George or Jorge build with these 3 rods? I'll be quiet for a moment. You can put the answers into the chat. Okay, really good work. So just start with one of the rods and try to test the possibilities and see if they work. I'm going to start with, right now I'm going to start with the middle rod. I'm going to start with the rod that shows 2 green triangles on the same side. So if I look at this, here's a rod with 2 green triangles, but they are on opposite sides. So A is not a possibility. Here are 2 green triangles, again on opposite sides, so B is not going to be the correct answer. C doesn't have 2 green triangles on a single rod going across, so that is not a possibility. And if I look at D, again, I have these 2 green triangles, but on opposite sides, so it doesn't match this option. So E looks like it could be correct. Let's double check. I have 2 green triangles on opposite sides. So that's this first rod, the middle rod, I should say. Then on the left-hand rod, I should have a square and a triangle on the same side. And I do, they're upside down, but the square and the triangle are on the same side of the rod, and the squares to the left, the triangles to the right. And then the final third rod, I should have squares on opposite sides, which I do. So a lot of you have it correct in the chat. The correct answer here was E. And progressive, this got much more difficult all of a sudden. Now we have a 3-dimensional shape. Tino combines the 3 building blocks shown on the right. Which of the following constructions can he make? I'm going to go ahead and work this one right along with you. The first one I'm going to eliminate is B. Maybe some of you can put in the chat why I'm eliminating B. We have actually a 2-story building, a little 2-story building here, right? And I have no 2 stories in B, so I cannot use B. Then if I come and I try to do something with A, let's see. I have 1, 2, 3, 4. That could be this piece right here. That works. And then if I try to do this little triangle, this little 3-piece, there's a little lag in my drawing, then this, I cannot fit this piece in on A. So A doesn't work and B doesn't work. If I try C, I'll focus on this one that has 2 stories. So I can have two stories like this, or I could turn it so it goes in either of those directions as well. But if you notice, if I turn it, then I would have an empty space right here. And I don't have an empty space anywhere. So I would have to fill it in. I would have to, how do I get it into these corners here? I'm not quite sure how I would get a piece into those corners. So C is not going to work. If I look at E, if I want to turn these pieces so that these are 2 stories, I could rotate these up, right? This piece and this piece could be rotated so that I had a bottom story and a second story. But that gives me only 3 pieces that would come up, and this has 4. So there's no way to construct E out of the pieces, and the correct answer is D. You can convince yourself by drawing over it. I have maybe this piece here. I would have this piece back here. And then I have the taller piece with the long leg, the L-shaped piece on the left side here. So hopefully that helps you see all of the pieces. All right. Now let's do a little bit of reasoning, some algebraic thinking. This is where we say Math Kangaroo takes you beyond grade level. You're not going to see this type of multi-step problem in your typical first or second grade class. A dog has 2 puppies that weigh the same. The first picture shows that the dog and 1 puppy together weigh 14 kilograms. The second picture shows that the dog and both puppies together weigh 18 kilograms. How much does the dog weigh? So we want the adult dog's weight. And there is a poll for this slide. Wow, of the students who've answered, we have a unanimous answer in the poll so far. Does anybody else want to add something? All right. Good job, everybody. So if I share the results, it was almost unanimous that the dog weighs 10 kilograms. That is correct. The reasoning for this problem, it's a little bit of an algebraic thinking type of example. I know that the difference between the first picture and the second picture is 1 puppy. So if I take 18 minus 14, that equals 4 kilograms, and that is 1 puppy. So if I take the first one and I take the 14 kilograms minus the 4, that equals the dog. So that is the 1 adult dog is 10 kilograms. B. You did really, really well on that problem. I hope you like the illustrations as well. A pair of scales is used to weigh 3 different types of objects, and the results are shown below. Which type of object? Each type of object has a different mass. The masses can be 1, 2, 3, 4, or 5 kilograms. What is the mass of one of the red squares in kilograms? So this does limit you. We can only assign them to be 1, 2, 3, 4, or 5 kilograms. No others. So don't try to make one 100. That won't be one of our answers here. And what does the scale do? What do these balances do? What does it mean when one is down and one is up? What does that mean? I'm going to launch a poll. Students, if you're enjoying these problems, you can let me know in the chat. You can give me a little thumbs up or a smile. Let me know you enjoy it. So anybody else? I'm going to offer a hint. So if you can still see the slides, I'm going to advance to the next slide. If you don't know where to start with this, try to figure out which shape is the lightest or which shape is the heaviest and assign it. So if you figured, I know one is the lightest, I'm going to make it 1 and then see if you can figure it out. If you prefer, you can say, I think this one's the heaviest, and you can make that a 5 and then see if you can figure out the square's mass. I like when it's equally good that you can do it 2 ways. All right. Anybody else want to put the answer in the poll? I'm going to stop the poll and I'll share the results. They're a little bit more mixed. We do have half of you, 50%, saying that you think that the red square is 3 kilograms. Let's take a look and see. So remember I said there was 2 ways to solve it, and that's fine. It doesn't matter where we start. So how do I figure out what is the lightest object? The lighter objects, those that are less massive, are going to be going up, right? So this is lighter, and this is heavier. So 2 stars are lighter than 1 square. So let's make each star 1 kilogram. So this square has to be heavier than 1 plus 1, or heavier than 2, so let's make it 3. Now if I look at the second balance, I know that each one of these is 3, so that gives me a total of 9, correct? I have to do 3 times 3. So now 2 of these green circles has to be at least 9. Let's make them 10. And that means that each one is 5. That would work, right? Because 10 divided by 2 is 5 each. Now, did I break these rules, or do I have it that the masses can be 1, 2, 3, 4, or 5? I've used the 1, the 3, and the 5, and it works, right? If I assigned the green squares to be 5 and I worked the opposite way, I would get the same answer, which is C, 3 kilograms for that red square. All right, let's see how we could make this a bit more challenging for the older students. Let's see what we did for level 5, 6. Same idea of a balance problem, but now you can see we have nested balances. We actually have 1, 2, 3 fulcrums on this balance. So quite a bit more complicated. Some blocks are balanced on top of each other as shown. Blocks that are shaded in the same way have the same weight. Does that make sense? So if it's a gray with an X in it, all those gray X's are the same weight. Vil wants to order the 3 different types of square blocks from heaviest to lightest. Which order should Vil obtain? So make sure you're doing heaviest to lightest, not lightest to heaviest. And I'll give a few moments and then I'll provide a hint. I'm good at hints, right? If you think you know it without a hint, you can put the answer into the chat. There is no poll for this one. like to provide hints too early because I know some of you really enjoy trying to figure it out yourself, right? I'm that way. Like, don't interrupt. I'm thinking. All right, let's provide a hint. We can ignore some blocks. If they appear on both sides of the balance, then they're not really going to affect which way the balance moves, right? So if I look at it and I ignore some blocks, I notice that there's a dark gray. Oh, sorry, my pen isn't writing. There's a dark gray on this side and a dark gray on this side. Right now, I'm looking at this part of the fulcrum. I'm balancing from the whole left to the whole right. So if I cross those off, I also had a block with an X here and a block with an X here. A little lagging. So I can cross those off. Right now, if I divide this into two, I can see that two of these speckled blocks equals three of the X blocks. So which is lighter, X or speckles? The other thing I can do is you notice I have a fulcrum just over here on the left-hand side. Once I figure out if X or speckles is lighter or heavier, then I can take a look at this piece right there to determine what I can do with those shaded dark gray blocks. Does that hint help? All right, so let's write down what we've discovered so far. On the left-hand side, we know that two of the speckled blocks equals three of the X blocks. So the X blocks must be lighter. Remember, lighter is going to be on the right-hand side. So I need the X blocks to the right. So if I was drawing it all together, I have the speckles is heavier than the X's. Now let's take a look at what I have here in orange. I know that two speckles weighs the same as an X and a gray block. Well, the X is lighter than the speckle, so that the gray block must be heavy in order to add a little more mass and balance out the two speckles. So the heaviest one is going to be the darkly shaded block. So what matches this? I have to have dark shaded, speckle, and X, so I have choice A. Tricky problem, right? I hope you liked it. All right, one of the best things I like about math problems is when they seem like puzzles, a little like games. I love to have myself a good game with math problems or with logical reasoning. Aria decides to paint each square in the shape shown so that squares painted the same color do not touch. She paints 4 squares red, 3 squares blue, 2 squares green, and 1 square yellow. Which color did she paint in the square marked with the X? And your choices are red, blue, green, yellow, or it's impossible to know. How could I possibly figure that out? No one knows. We don't know what she did. All right, we haven't had too many polls for the younger students, so here is your chance to have a poll. What do you think the correct answer is for the color of the square with the X? And this is a tricky problem. There's a question, can they touch between the rows up and down? No. So On no sides can it touch. So if I have a red square someplace, there cannot be another red square that touches it either above, below, to the side. It has to have different colors next to it on all the other sides. Okay. I'm going to end the poll. So if you want to put your answer in real fast, I'm not going to share the result yet, though. You ready? Everyone have their answer in the poll? Can always guess. I don't know who you are. It's anonymous, right? Okay, let's take a look at a hint. So one way to do this is to realize that we have these cool little three by three triangles that surround the X. Is that neat? So in each one of those, I need to have 4 reds total. So I need to have a red in each one of those, and they can't touch each other. So the best place for, I think, if I can only have 1 red in each one of those, so I must put a red for the 4th one in the middle, right? Because I can only put 1 red. I can only put 1 red here. It can't touch the one in the middle. I can put 1 red here and 1 red here. Now, what could you do if you did not see that? If you didn't see that there were 3 little triangles kind of stacked on top of each other? If you don't see that, then think there's 4 reds. That's more than anything else, right? So how can I put 4 reds so they're the most spread out so that they're not touching each other? So that's a good approach, is to spread them out as much as possible. So put them on the corners, and then you can find that there's 1 in the center. Should we see how you did on the poll? There you go. Over half of you got it correct. Not everybody did, but that's just to show you that this is a challenge. And we want there to be some challenge in the Math Kangaroo contest. We don't want it to be super easy, right? When things are too easy, it doesn't teach us too much. We want to be learning all the time. Bob makes a square from 4 rectangular pieces. 3 of the pieces are shown. Which of the following is the 4th piece he uses? I found this one to be challenging. The students that I've worked with in person have also found this to be a challenging problem. In about a minute, I will give a hint that might help. So we want to make a square. And whenever we make a square, we have to have the same dimensions for the length and the width. This is our longest piece right now, and this is a 6 by 1. So that might be a good hint for you. Think about what kind of square you can make if it has to be including that 6 by 1 piece. All right, if we include this 1 by 6 piece, we know that the smallest square we can make has to be a 6 by 6, and that would be 36 squares. This one has 8. This one has 10. This one has 6. If we add that together, so far we have 24, which means we need 12 more small squares. So if our answer choice does not have 12 more small squares, we can cross it off. Now we're left with 2. Still don't have the solution yet. Yeah, I have students doing real well in the chat. You're getting it now, right? So now if you know it's D or E, try drawing it. See if you can put them together. And when we try to draw it together, we'll notice that the piece that fits is E. You can see that E fits right here. This piece is E. Right? So we put our long 1 by 6 on the bottom. And then we had a 5 here. Oh, my pen, such a lag. So that works perfectly. Here's another kind of a puzzle. I like this one a lot, and I think you will too. Patricia wants to write the numbers from 1 to 9 into the squares in the diagram, with one number in each square. She wants the sum of the numbers in any 2 adjacent squares to be equal to the number shown on the line joining these squares. What is the sum of the number she writes in the shaded row? Critical reading skills here, right? What does all of this mean? We can only use the numbers 1 through 9, and there are 9 squares, so we must use each of them. We can only use each one once. What does adjacent and joining mean? It means, look, we have a 9 here, so this plus this must equal 9, right? It tells us the sum must equal 9. And then we have to be real careful because the answer is in the form of a sum. What is the sum of the numbers in the shaded row? This will be our final poll today. So here is your final poll. Some of you have noticed that Lucia Liu is still here with us. She recommended to me that if you're having trouble with a problem and it seems like it's taking too long, it's too hard, there might be a trick you need to find. I found the trick in this problem. I'm going to end the poll in about 15 seconds. I know this one's tough. It's supposed to be. It's one of our 5-point challenging questions for level 5-6. So this will be a tough one. I'm going to end the poll. I'm not going to share the results, but I do want to say that only about a quarter of you completed the problem in the poll. So I know that this one was tricking you. I know it's hard. It's supposed to be. Remember, we want to challenge, we want to learn. If we do only the things that we already know how to do, we don't grow, we don't learn how to advance ourselves. And we're trying to get better and better and better and better all the time. So one of the things I noticed about this problem, you could do this problem if you love algebra, if you're a 5th, 6th grader and you love algebra, you can go ahead and you can stick some variables into here. You can put some A, B, C, you can go all the way up to F, G, whatever, and you can start to make some equations and try to solve them. But if you do that, you're going to notice this is going to take a long time. So what was that trick that perhaps I found? Well, when I looked at this problem, I noticed something about it, which is that there's 1, 2, 3, 4 different sums that equal 11. So now I only have the numbers 1 to 9. How can I make 11? Well, 2 plus 9 is 11. 3 plus 8 is 11. 4 plus 7 is 11. And 5 plus 6 is 11. Do you notice there's one number between 1 and 9 that I didn't use yet? Some of you could throw that into the chat. I bet you figured out that I can't use the number 1 because 1 plus 9 is only 10. So which of these squares is not adjacent to a number 11? This one. It must be 1. Once I figure out that that is 1, we can fill in all of the other boxes together. So 10 minus 1 is 9. 9 minus 1 is 8. 11 minus 8 is 3. 13 minus 9 is 4. 9 minus 4 is 5. 11 minus 5 is 6. It can go in any order you want. 9 plus 2 is 11. You can do 4 plus 7 is 11. And now remember, the answer had to be the sum of the numbers in the shaded row. So I have to do 5 plus 4 plus 9. And so the sum is 18. Now you might be wondering, okay, I know not a lot of people answered the poll, but what did they do? What answer did they get? And congratulations, several of you did get it correct that it is 18. Really challenging problem, so really good job getting that correct. Congratulations. Okay, that is all the time we're going to have for solving problems today. I want to show you what you can do next, right? Did you like these Math Kangaroo contest questions? If you thought they were challenging, if you thought they were fun, then what you want to do is get more involved with Math Kangaroo. You want to do some fun things. So you can do summer learning classes with us. We have summer learning classes. If you're interested in that, you can go ahead and scan the QR code for summer learning classes. If you want to know more about Math Kangaroo, make sure that you know about special seminars, webinars, and other things that we're doing, what classes we're offering, that you don't miss the registration for the contest for our monthly newsletter. It's emailed just once a month so you know what's coming up that month and if there's a deadline coming up or anything like that. If you would like to bring this to your school, if you are an educator, if you have a principal that you know really well and you want your school to offer the Math Kangaroo contest so you can do this with your classmates, that's what that new center link is for with the QR code. So let your teachers know, let your principal know that your whole class could do this, or you could have a math club that does this. I coach a math club. My math club takes the Math Kangaroo contest. We are planning to have even more webinars. We have a monthly solve that is done of our contest problems. We have a professor who joins us for those. So sign up for the newsletter and you'll see all that information. Okay, I want to thank Joanna and Lucia who have been answering your questions in the Q&A. Thank you so much. Hopefully a lot of people have answers to their questions. If you did not get those QR codes, I know they were kind of fast. Here's your opportunity. If you let me close the webinar, you're going to get a link to a survey. It's really, really short. I know you don't want to do a long survey. So in that short survey, you will be able to just check off boxes for what you want us to send you email with more information. Really, really simple. Okay. Also, if you don't mind, there's one question where we said, what is the best thing about today's webinar? And I still have a question. I don't know where to find the answer. You can put that right in there. There's a box for more questions. Okay, so hopefully you enjoyed the webinar today. Remember, I covered questions from difficulty levels from 1st to 2nd grade all the way through 5th and 6th grade. So if you're not a 5th or 6th grader and you found those questions really challenging, it makes a lot of sense if you're not in those grade levels yet. Okay, so just make sure you understand that we mix them together. We wanted to try to cover all of elementary school because we want to show you how you can grow with Math Kangaroo. It's not just you take it once, you can keep taking it as you grow older. So thank you very much for your attention today. Thank you, Joanna Lucia, and we hope to see you signing up for more of our Math Kangaroo endeavors. And enjoy math, make it fun. Bye, everybody.